Let's first take a look at a video. This video features a beautiful woman flipping her hair. Everyone, take a look. The overall sense of motion is very beautiful. This video was generated by the Wan2.2 I2V model. If we only look at this video, many people might think that the quality of this video is very high. But I am telling you now that this video has a problem. So where exactly is the problem? Let's look at another identical video. Let us synchronize them. I don't know if everyone has noticed the difference. Actually, the first video has a slow motion effect. The second woman's hair can swing to the front of her body. However, the first video ends when the hair reaches her back. The reason is that the overall speed of the first video is relatively slow. When we look at this video in isolation, the feeling is not significant, but when we compare them, it becomes quite obvious. However, I think many people might feel that the overall aesthetic appeal of the first video is better. This is because the slow motion presentation seems more suitable in this particular scene. But you must pay attention, this kind of slow motion is not just present in this one scene. This issue might exist in all scenes. In that case, this cannot be called an advantage, it can only be called a problem. The technique we are discussing today is mainly used to solve the Wan2.2 model's slow motion and the issue of limited movement amplitude. This technique is called painterI2V. It is essentially a node, and it mainly addresses two problems. The first is to reduce slow motion, allowing the movement amplitude to increase by 15 to 50%. The second is to enhance the camera movement effect. We can see some examples below. For instance, looking at the boxing example in the middle, when using the native node of the Wan model, it is actually in slow motion. But after we use this new node, it is basically back to normal in the workflow. This technique appears simply as a node. The function of this node is the same as our OneImage2Video node. Therefore, when you use it, you only need to replace the traditional OneImage2Video node with our painterI2V node. Additionally, the movement amplitude of this node is controlled by a parameter. There are also some recommended settings for this parameter. If you are generating a fast action such as running or jumping, then a setting of 1.25 to 1.35 is sufficient. If it is a normal action, 1.10 to 1.20 will suffice. If you only want simple dynamic enhancement, 1.0 to 1.10 is enough. This depends on the specific situation. Furthermore, we should mention that if you are using the Wan2.2 I2V workflow from Kijai, you had better use his other set of extended nodes. There is a corresponding link here. Similarly, I have built this workflow on Running Hub. Everyone can access this platform through Running Hub. In the field of ComfyUI, Running Hub is an excellent online workflow platform. This is because as soon as new technologies and new models appear, Running Hub follows up immediately. You can register for Running Hub using the invitation link in the video description. This grants you 1,000 free points. In addition, logging into Running Hub every day also gives you 100 points. This allows you to try out your own workflows. Next, let's look at the workflow. This workflow is actually a comparison workflow. Note that the front part is shared. Let's take a look. This is our reference image. The current image I am using shows two beautiful women drag racing on motorcycles in the rain. I am using a resolution of 832 by 480. I use the native Wan2.2 I2V model. I also used an acceleration LoRA here, specifically light X to V. Let's talk about the cause of the slow motion problem here. We have a technical term for this, latent space residue. This latent space residue refers to the fact that after we use the light X to V LoRA, the latent space is actually impure. The biggest feature of the node we are discussing is that it generates an all-zero latent space. This provides a better foundation for subsequent video generation. Therefore, the original Wan2.2 model does not have this problem. In many cases, this problem only arises after we use an acceleration LoRA. Regarding our VAE encoder and visual encoder, the settings are the same as traditional setups. Now, let's discuss the prompt. I am still using QWNVL, which generated a JSON formatted prompt. This is very important. Many people who test this model find the effect is not significant because the scene they generate lacks sufficient dynamic movement. There are generally two reasons for this. One is that the image they selected does not have enough dynamic feeling. The second is that the prompt they wrote does not highlight better action. The reason I use a JSON formatted prompt here is because it generates more dynamic motion. If you recall, when we discussed the QWNVL model, we mentioned that it designs an action for every second. Therefore, its sense of movement is sufficient. Next is the most crucial part. We call it the OneImage2Video node. This is the primary node that causes the problem. For comparison, I have two similar nodes here. The first is the OneImage2Video node from the native Wan2.2 workflow. Below that is our painterI2V similarly. We have two samplers. Note that all sampling conditions, including the sampling steps and our seeds, are identical. I have fixed the seeds to 42. The denoise model is 0 for both. Therefore, the overall conditions are completely the same. The difference between using painterI2V and not using it is quite obvious. Let's look at the generated results. This video shows the result without using the painterI2V node. We will find that this video is very run-of-the-mill. Looking at it alone, we might not see any flaws, but compare the two. Let's synchronize them again. Look, the camera work here is much more agile. This one is relatively stiff. As we mentioned when discussing this model, it primarily solves two problems. The first is reducing slow motion, and the second is enhancing camera movement. What we are seeing now is an example of the enhanced camera movement effect. Of course, this is also related to the setting of a parameter. We also mentioned when discussing this node that there is an action amplification control parameter. Here I set it to 1.3. 1.30 is relatively large and it should fall under the category of fast action. For videos involving running or jumping, using 1.30 is more appropriate. Below are the examples we just saw. You will find that this is clearly a slow motion. And this is the case for a normal video. Let's look at another one. This is a model on the catwalk suddenly turning around. Her skirt swings up. The sense of motion is also sufficient. Let's synchronize them both again. Let's look at this one. First, the slow motion feeling is very obvious. Although it makes you feel beautiful, it is undeniable that the sense of slow motion is very prominent. Now let's look at this one. This is a very normal turn. The movement is also very smooth. The latter video is more consistent with the appearance in a realistic state. Let's look at this one. This woman is running in the jungle. Although she is running, it is still in a slow motion state. Now, let's look at this one. The entire dynamic feeling has been enhanced. Many people might say that they can't really see how big the difference is. Notice that their starting positions are the same, then they start running. Pay attention. When they reach the end position, you can determine the approximate speed difference by looking at the proportion of the screen occupied by the body. So, by finding a reference point, it is easier to find where the gap lies. In addition, you should notice that this node also seems to include some color correction. In this video, the overall state is yellowish. However, after using this node, cooler colors appear. This is especially noticeable in the blue sky and the trees. Let's look at this one again. This is very obvious. Everyone, look. The jump here is clearly slow motion. Then the spike begins. Although it is full of dynamic motion, it makes us easily think of it as a close-up slow motion shot. Now let's look at this one. It is much more normal. I have demonstrated several examples for everyone. These examples fully illustrate the function of this node. I did not use other models here. This is because non-official models tend to have larger discrepancies. Sometimes they cannot explain the problem very well. When evaluating the quality of a technique, we must have a benchmark model. Therefore, we still use the official Wan2.2 I2V model as the benchmark. This makes it easier for us to determine whether this technique is effective. Okay, that is all for today. What are you waiting for? Go try it yourself. Follow me to become someone who understands AI.